Hello and welcome to this session about 50 new things you can do in Java 8. In fact, 50 is a bit of a crazy number. I could have said 36 or 63.15, something like that, because it's more than 50. You'll have for your money, don't you worry. Of course, Java 8 is all about lambda expressions, about the stream APIs, about the collectors, about JavaFX. We have a new JavaFX version for the graphical user interface, about Null also, which is the new JavaScript engine. And what I would like to show you in this talk is to show you new things without talking to you, neither about lambda expression, neither about the streams, neither about collectors, neither about JavaFX, and neither about Null. The real question is, what is left once we've removed everything? We removed everything that is new, and what is left? And you can trust me, there is enough to pack a nice 50-minute sessions. What I would like to show you is all those little gems, little diamonds, scattered everywhere in the JDK 8, and that you will probably be using at first. Because if your project moves from Java 6 or 7 to Java 8 just now, probably this critical business logic layer that you have won't be refactored to leverage the full powers of lambda expressions and streams and collectors and stuff before long. Because it's precisely critical how to maintain, how to test, probably not completely tested, and this will not be done at once. But there are still many things in Java 8 that we will be able to use just now as developers, and that we will make our developers' life much easier. My name is Jose. I'm an assistant professor at the University of Paris 13. I come from applied math and electrical engineering. I also work as an open source developer and as an independent in Paris area and in various cities in Europe. I do training, Java training for the moment. I also have a blog, so sorry, it's a blog in French, so it might not be that useful to you. But it's still nice, there are nice pictures on it. And I also have a Twitter account that you can follow. And if you have questions, please use this hashtag. I might not have the time at the end of the session to answer them, but you can catch me in the conference venue or on Twitter, and I'll be glad to answer you if I can. Okay, so the first API I would like to talk about is the Java Date API. We've been running with this Java util date for too long now, and we could say at last, we have a really great API to deal with dates and times in Java. This date and time API is built on the notion of timeline, so I have a timeline, and I've got points on that timeline, modeled by the instant class. Here are the patterns to build one. Between two instants, I have a duration. A duration is just the time elapsed between 2 points, precise points on this timeline. I can express a duration in various units, like milliseconds, here. And I've got methods to add specific time lapse to that duration. For instance, if I want to add second to a given duration, I can do it like that. Great. This timeline has a precision of a 9-second, 10 minus 9 seconds. Now you can think it's a high precision. Well, it depends. About 2 years ago, some guys between France and Geneva discovered a particle called the Higgs boson. Maybe you've heard of that. And the half-life of the Higgs boson is 10 minus 23 seconds. So if you want to go into particle physics, maybe this API won't be the good one to do that. But it's still nice precision. Now, this timeline has a high precision, and it's not suitable for all the dates we have to deal with in our applications. So I've got other concept, the concept of local date. A local date is just that. It's an everyday date. For instance, the 23rd of April, 1564, date of birth of Shakespeare. It is a local date. It is not an instant of the timeline. It's just a local date. And of course, with the local date, I also have the notion of period, which is the time elapsed between two local dates. I can build periods just like that. Now, a period is expressed in years, months, and days. So if I call the getYears method, I'll get the number of years. If I call the getDays method, I don't have this period of time expressed in days. I have the number of days in that period. If I want to have the number of days that period is about, I need to pass another parameter to the until method, which is the unit I want to express this period of time in, and I will have the number of days of that period. Okay? To do arithmetic on this concept of local date, I have a temporal adjuster class, and this is a very nice class. It's in fact a toolbox. There are 14 static methods in it, and I can do really wonders with that. It will help me a lot in my project. If I want the first day of month, then I can just add that amount of time, and I will have the first day of next month. If I want the next Monday, or the first Monday of a given month, I also have methods for that, which is just great. It will save me a lot of headaches, because programming that is not that easy. Okay, this is for the temporal adjuster. And since I have the local date notion, I also have the local time notion. If I give a rendezvous for a friend, let's meet tomorrow for lunch at 12. This is not an instant in the timeline, this is just a local date. And every day, sorry, a local time, and everyday time, I would say. Let's say 10:20. The local time is also linked to a special kind of arithmetic, so I also have a bunch of methods to add special amounts of time to a local time. Great. And then I have this amazing class called zoned time. Of course, one of the greatest pain when we deal with date is the time zone. There are many time zones all over the earth. You can imagine that in the US it's not the same time as here. This is crazy, but it's like that. So at last we have the time zone included in the JDK, so I can get the time zone just by this method, zone ID off, and pass the name of the time zone as a parameter. And a zone time is built on an instant of the timeline bound to a given time zone. So to build the zone time, I've got this method. It may look a little hard to understand, but in fact, the first parameters are the year, the month, the day, then hour, minutes, seconds, and nanoseconds. So this is an instant of the timeline. And then a time zone. So I bind this instant of time to a given time zone, and this gives me a zoned time. And of course, I have arithmetics on zone time, just as I have on instance, of course, and I can convert this zone time from a time zone to another one. This is the same instant bound to a given time zone, and I want to bind this same instant to another time zone. And to do that, I've got the method with zone same instant. So this is the same instant, but expressed in another time zone. Lots of headaches saved by this simple method, I guess. Great. And then I've got formatters to do that, because of course, everybody has its own idea about how to print out a date on a screen or in a log file. So I've got a date-time formatter class with a bunch of predefined formats. Most of them are standardized formats. So here I give 2 examples. So I can print out dates very naturally and very easily with this API. And of course, I need bridges between the legacy API and this new Java Date API. So I've got several methods to do that. I can link Java util date to this new instant concept with those 2 methods. I can go also from timestamp, the old timestamp from Java util package, to the instant. I can also link a date to a local date, Java util date, and of course, a time to a local time. So I have all the bridges I need to go from my legacy code to this new API. Now, the only thing I'm still missing is the support in JPA, for instance. I don't have the support in JPA. I can think that we'll have it in the future, but for now, we don't have it. This API is really great. It could make a whole talk in itself. Go check it. The documentation, the Java doc, is really a masterpiece. It has been extremely well documented, so please go check it if you're interested. Second, we're going to talk about the string class. You won't believe it, but there are modifications in the string class in Java 8. Okay, we've all written this kind of code, how to concatenate strings. You can't believe that it's that complicated to concatenate strings in Java. So when you see someone write like that, oops, sorry, made a mistake. This is the next item. All right, so this is a char method. It has nothing to do with concatenation. We can open streams on strings. So this char method opens a stream on the letter that this string is made of. It's an int stream, so if I want to print out the letters of that stream, I guess I can write that kind of code to put it in uppercase. It might be the easiest way to put a string in uppercase, of course, but it should work. And hopefully, it will print out this. But in fact, it prints out that, which is not nice. Why? Because the char is an int stream. So the system.out.println prints an int, which is not what I want. If I want to print the characters, I need to convert it with this odd piece of code. This is just to convert the letter, which is an int, to a letter that is a char, and to box it in a character object. And this will work as expected and print me out hello. I also have another way of building streams to build streams on strings. In the regular expression API, I've got this new method, split as stream. Suppose book is a huge string of characters, and I want to cut it out into words with this regular expression. Then I can build a stream on that, all the elements of the stream being the different words cut out by my regular expression, which is great also. And I come to the concatenation. To concatenate strings in Java, we can write this kind of code. And of course, we all know that this is not the right way to do it. Yeah, right? What is the right way to do it? Yeah, probably this one. String buffer. No, string buffer. No, probably not string buffer. If you write this kind of code, somebody will come to you and say, no, don't use the string buffer because it is synchronized. And that is true. There is a synchronization in the string buffer. You should be using string builder. Why? Because string builder is not synchronized. In fact, it's not completely true because the JVM is smart enough to recognize that when a synchronized block is not used in a multi-threaded environment, it can, in certain cases, remove the synchronized block. So probably most of the time, the performances of both will be roughly the same. But in fact, the newbie was right. You can write that in Java 7. Because if you check the bytecode generated by the compiler, you'll get this one. And you see that the compiler is smart enough to do the string builder stuff for you. So just let the newbie alone and let it concentrate on other things. Okay, but in Java 8, we have a new class called string joiner. What does the string joiner do? It just does that, joins strings. So I can build a string joiner on a separator. Here it's just a comma. Add content to it with this nice chaining calls of add method. And then call the toString method, and it will nicely print out this, which is nice. Of course, all the corner cases have been correctly handled. So if I have only one element in my string joiner, I won't have the separator. So you can throw away your code that will add a separator, then remove it, and blah, blah, blah. Okay? We've all written that at least 10,000 times, right? And the string joiner can also take a prefix and a postfix as a parameter. So I can also do that. And of course, all the corner cases have been correctly handled. So no separator in that case. And if my string joiner is empty, of course, I will have that, which is great, which is great. We could have received that class 15 years ago, but it's in Java 8 that we have it. And guess what? It also has been introduced in the string class directly. I've got this static method join that takes a parameter, which is the separator, and that does it just the way I'm expecting it. So the second arg is a var arg, so I can pass any kind of array with it. And I also have a version that takes an iterable, so I can also pass an array or any instance of collection to that method. Unfortunately, that method doesn't have a version with a prefix and a postfix. So if I need the prefix and the postfix, then I need to fall back on a string joiner. Great. I've got some new things on numbers too. You know those number wrapper class? I've got three methods on it, a max, a min, and a sum method. So now I can write this kind of code. Now, you could tell me, is it really that useful to be able to write long.sum 1 and 2 instead of 1 plus 2? Okay, it might not be that useful, but when I'm writing stream code like that, The last parameter is a reducer. A reducer is written like that, but I can also write it with a method reference like that, thanks to this method. So in this case, I think that this method is useful because it's much more readable code. This is a personal opinion. But I have also other ways to write this. I can also write that, and I can also write that for the stream. So I've got, in fact, many ways of writing that code. We'll come later on this comparator interface too. I've got new stuff to compute hash codes of longs. Now the hash code of a long is not the long itself. It's because an hash code is an integer, so you have to do some computation. And in JDK 7, the right way of doing this is to wrap the long in a wrapper class and call the hash code method on it, which is not optimal, of course, because I need to box this long, and I want to do that. So now I have this static method on the long class to compute the hash code without paying the cost of boxing, which is great also. I've got new thing in Java I/O linked to the stream API. First, the stream interface extends auto-closable. So I can pass stream constructors or stream to the patterns that build the streams inside a try with resource of Java 7, and the close method will be called for me, of course, when I leave that block of code. So I've got this new lines method on the files class. I give a path as a parameter, and it opens a stream of strings on the text file that this path is built on, and every element of that stream will be a line of the given file. So this is basically a one-liner to read a text file line by line automatically in a try with resource, which is very nice. I also have a list method in files. What does this method do? It just lists me the content of the given directory. The path is supposed to be a directory. It doesn't explore the subdirectory, so it's just what is inside the directory, but it does not explore, it does not go into the subdirectories. If I want to go into the subdirectories, I have this walk method to do that. That will explore the full depth of the directory. And if I want to limit the depth of exploration, I can pass another parameter to this method, which is in this case 2, which tells the maximum depth I should explore. Great. I've got new stuff in the collection framework. Of course, the biggest stuff is the stream method, but I've got other things too. On iterable, I've got a for each method, so I can build array and consume all the elements of my given lists one by one with this for each method. Gives me this code. Unfortunately, and for some reason, an array is supposed to be an iterable, but this for each method doesn't work on arrays. It has not been implemented for arrays. I also have a remove if method on collection. This remove if method takes a predicate as a parameter and will remove the given element of the collection one by one for the element that pass the predicate. So in this case, 1 to 4. It works in place, so your collection has to be mutable, of course. I've got a replace all on the list interface. A replace all takes a special kind of function called a unary operator. A unary operator takes an object of a given type and returns an object of the same type, of course. This transformation is made also in place, and it's just a computation on the different elements of the list. And guess what? I got a sort method on list. And this is just crazy. We've been waiting for this method for 15 years. Can you imagine that? But now we have it, so we're happy with that. Okay, I just need to pass a comparator to this sort method, and it will sort the list in place. So long with this collections.sort, that stuff, kind of weird code to write to sort lists until Java 7. And can you see the new way of writing comparators in Java 7? Let's talk about those comparators precisely. It's really a lovable new API, and it's a great example of what can be done with the new stuff in Java 8. So this is a comparator natural order. It will just compare objects that are already comparable. Great. Maybe we can zoom a little on the implementation of that method. It's a static method from the comparator interface. So this is the old comparator interface we've been knowing for so long. And if I check the code of that, it just comparators.naturalOrderComparator.instance. Now, what is this natural order comparator stuff? It's interesting to have a look. It's just this. It's an enumeration. that implements comparator. Yes, an enumeration is in fact a special kind of class, so it can implement, indeed, interfaces, which is the case here, and it has only one instance. So what is this? Well, in fact, it's a singleton. This is the right way of writing singleton since Java 5. Java 5 is 2004, so since 10 years. And I'm sure that nobody in this room would have the weird idea to write this kind of code to implement singletons. Sorry. So I can add methods to enumerations, of course. So here is the compare method, very classical. And the reverse method, which is another method of the enumeration that we'll see in a minute. So how can I write comparators in Java 7? If I want to compare person by using their last name, I will need to write this kind of code. This kind of code is not very robust, because if one of the two instances of person is null, then I got a null pointer exception, which is not nice in my code. And if I want to compare by last name, then by first name, I will end up writing this kind of nice piece of code, probably not very readable, not very easy to write neither. And if I want to then compare by age, for instance, I need another slide, so I won't show you the code, but I guess you could write it too. Now the Java 8 way is this one. I've got the comparing by method in the comparator interface. It's a static method from that interface. And I just pass a key extractor that works on the type of this comparator, and that will get the property of that object to be compared for that comparator. And if I want to change that comparator with the first name, I've got this default method, then comparing, that takes another key extractor on the same object. So now I can write the get h2 because I just need to write just one more line of code to do that. And I think that this particular example is typical of what can be done with static method and default method on interfaces. Of course, default method on interfaces is a good way to enable one to add methods to given interfaces without breaking the existing implementation. And this is the first goal, of course, of the introduction of default method. But there is also a side effect, a new way to write APIs, a new way to write interfaces, and this is a very good example of it. This should be an example for the design of the new APIs post Java 8. Great. If you don't like the natural order, you also have the reversed order, which is basically the same, but the reversed, right? And if you want to reverse a comparator, okay, you can write a comparator and call the reversed method on it just to reverse this comparator. So I can do really many things on comparator, and it's great. And what about null values? Null values are always in my way when I want to sort lists or things like that. I never know what to do with them. Do I put them in the middle? Do I put them at the beginning? Do I put them to the end? Should I remove them? Well, I've got this nulls first method. Nulls first mean that the null value will be put at first when I sort my list. And if I got nulls first, you can guess that we also have nulls last. Okay? If you want to put the null values at the end of the list, which is great also. I've got new stuff on the map interface. We got some intention to the collection and iterable stuff. We also have new stuff on map. I've got a for each method on a map that takes the key value pair, that takes a big consumer on this example. I've got some new behavior of the get method. Now if I execute this code, what happens if the key is not in the map? Yes, I will end up with the result which is null. But if the key is sorry. Okay, sorry, missed one. But if the key is in the map, but associated to a null value, then I also get null as a value. So in fact, the get method will return me a null value, whether the key is in the map or is not. So now I've got the get all default method that will return me a default value that I can pass, and that will tell me if that key is in the map or not. Now I've got a robust way to tell if a given key is in a map or not. It was not the case in Java 7. I also have different behavior with the put method. If I execute that code, I could erase the previous value linked associated to that given key. Now I've got a put if absent method that will only work if the key is not in the map. I also have a replace method. That replace method takes a key and an expected value. And if that expected value matches the key, then I will replace it by a new value. This is a new method on a map interface. And I also have a replace all. It works a bit like the replace all of the list interface. The replace all just takes a lambda expression, and that will make some computation out of all the key value pairs of my map and returns me, well, repopulate my map with those new values. So this is great also. I also have a new remove value that takes a key value pair. So removing is not just about removing a key. I can impose to remove that key only if it is associated to the past value. And I've got a family of 3 functions. The first one is the compute method that will tell the key at the parameter and the lambda expression. That lambda expression takes the key value pair and computes a new value for the given key. Now, if the key is present in the map, the person passed to that lambda expression will not be null. Well, it can be null if the null value was associated to that key, but most of the time it won't be null. But if the key is not present in the map, then this second parameter of the lambda expression can be null. So I need to expect that. But I also have a compute if absent method that only takes a key and that expects the key not to be present in the map. So if the key is not present in the map, then this new value of person will be computed out of the key. And I also have the compute if present, which does the contrary. It expects the key to be present on the map and associated to a value. And this time the person is not expected to be null because most of the time I don't have null values in my map. So these 3 methods, compute, compute if present, and compute if absent, are extremely useful, and we are going to see a pattern just in a few seconds to build B maps with that with just 1 line of code. Why? Because those 3 methods, along with the put if absent, returns in fact the value of the map. So I can change stuff like that. And the last method I have is the merge method. This is very useful, and this is something I need when I do parallel computation with the stream APIs. I've got 2 maps that are partially filled in on 2 calls on my processors, and then I need to merge them. So how does the merge work? It takes a key, the value I want to add to associate with that key, but probably this key is already associated to a given value. So then I'll call this lambda expression with the key, the existing value already associated with that key, and to compute the new value out of those 2. This is the way the merge method works, and it was really great. And with this, I can build B maps with just 1 line of code. What is a B map? It's a map in which the values themselves are the maps. So here is the example, map of string, and of map string of person. Now if I call the put if absent method, and it also works with the compute family of method, the put if absent method returns me the value either that has just been created or that was existing before. And since that value is returned, I can make a put in it directly. So this code will in fact put the 1 key in the map. If the key is not associated to a hash map, the lambda expression will be executed. What does it do? It just creates a new hash map that is associated to that key. If the key is already in the map, it means that the hash map already exists, and there's probably content in it, so I'm not doing anything. And in both cases, I'm returning the map, either the one that has just been created or the one that was previously created. So in that map, I can call the put method, it's a regular map, and put the second key with the last value. So writing B maps in Java is just now 1 line of code thanks to these new methods. It's great. Now we're dealing with a bit darker things in the JDK. We're going into parallel processing and multi-threaded concurrent stuff. I've got a new API. It's not a big API, but it's really great, parallel arrays. Now, for some reason, the parallel arrays were already ready for Java 7, but they didn't make it in Java 7. I've got 3 methods on the arrays class. The parallel set all that will initialize an array here of long, in parallel for me with a given lambda expression. I've got a parallel prefix, which is a reduction. In fact, it's a right fold, so it will reduce my array from the left to the right with a given reduction passed as a lambda expression here. And it also works in parallel for me automatically. And the last one, probably the most useful one, is the parallel sorting of arrays directly. So this parallel sort will sort the array in parallel and in place for me. So this is probably the most useful methods of the three. Great. I've got a new API based on a single class called completable future. Now the completable future is an extension of the future class. The futures class has been introduced in Java 5, Java Util Concurrent. How can I build a completable future? Just use the static method supply async, and then a supplier, for instance, reading a web page. This stuff will return immediately. It's not a blocking call, and it will launch this supplier in another thread. It's built on an executor service. And the results of this stuff will be wrapped in a completable future. Now, what can I do with this completable future? Well, it's an extension of future, so I can call the get method on it. The get is a blocking call. It will return once the read web page has been done. But what I can do is that I can chain calls on this completable future. That is, a completable future has a then apply method. So once my web page has been read, I can trigger the analysis of the content of that web page by getting the images, for instance, of that content. And since it is also a long call, which will involve network access and things like that, I wrap it with the then apply method, also wraps it in a completable future. So I can chain again and again, things like that. And it's not a blocking call, so the supply async will return immediately, so I can continue my stuff here, and all this will be processed in another thread. I've got the then accept method. The then accept method is the last method of this pipeline, because in fact it's a pipeline of tasks that will be chained together. And the then accept method doesn't return anything, and I just have a consumer in it that will print out the images or whatever. I don't mind. So this enables me to create pipeline of tasks, completely asynchronous, and it is the entry point in what we call reactive programming. Reactive programming is a buzzword. Okay, so let's get rid of those buzzwords, but it's exactly about that. I also have the then compose method. The then compose method is different. My get to use that one, it doesn't wrap the result in a completable future. So if get images returns me a list of image, I'll get that list of image, and the call will be blocking until the list of images is ready. This is probably not what I want to do. But if get images returns a completable future, or a list of completable futures, something like that, I will return with this list, and will be able to do a for each method, for instance, and continue to chain my tasks in an asynchronous way. And what can I do with all these completable future? Well, I can call the get method, which is blocking. Might not be the best of the idea, but I can also pass, this all-off method takes a var as an argument, so I can pass as many completable futures I want to this method. And the join method of this all-off call will return me once all the completable future have completed their tasks. I've got all-off methods that will wait for all the tasks to complete, but I also have the any-off method that will wait for the first task to complete. So for instance, if I have 10 calls on 10 different DNSs, because I just want to get the result as fast as possible, I can wrap them in an any-off, and it will tell me as soon as the first DNS give me the answer. And I can also combine this completable future. I've got many methods to do that. So I can build pipelines of asynchronous tasks and join them with several ways of combining them. Here the combining is made with a lambda expression. I've got other stuff. I've got also accept both, run after both. I can trigger runnable once my completable future have completed. And I also apply to either method that also takes a lambda expression which is the same kind of thing. The difference between this one and the previous one is the same as the difference between any off and all off. This will trigger as soon as one completable future has finished its work. And I also have accept either and run after either method to trigger things differently. So this completable future is quite a complex class. It's very powerful, and it's the key, it's the entry point to all the reactive programming in this new Java Util Concurrent API. On the pure concurrence front, I also have new things. From Java 5, I have the atomic long class with the increment and get method. Now I also have the update and get method that takes a lambda expression as the parameter. It works exactly the same as the increment and get. The only difference is I don't increment, I just apply this lambda expression. I also have an accumulate and get that takes a lambda expression and the previous value to accumulate stuff. It works the same, it's also casing, compare and swap. But I also have the long adder. Now what is the main problem of this atomic long is that if I have really many threads, thousands of threads on a given atomic long, it will compare and swap all the time, so it will not work very great. It doesn't scale very well. Why? Because I've got the increment, which is fine, but I also have the get. And most of the time, I don't need to get the result. I don't want the result at that moment. All I want to do is the incrementation. So this is exactly what the long adder does. I just trigger an incrementation, and inside, in the implementation of that class, I've got, in fact, a bunch of atomic long that can scale with the number of threads that are going to increment stuff inside my long adder. And since I'm not getting the result, I have less contention on that stuff. I'm just getting the result with the sum method, for instance. So on the sum calls, I do the computation over all the atomic variables inside the long adder. And I also have the long accumulator, which works the same with lambda expressions. So this is great for releasing contention with atomic variables. And I also have this new class, stamped lock. Now the stamped lock is just another read-write lock, so I can use it as a regular read-write lock. I've been doing that for 10 years now. Great, but I can also, the new stuff with the stamped lock is I can do also optimistic read with that. Of course, the read and the write are exclusive, but I can also write things like that. I take a stamp with this stamped lock, use a variable that is protected by this stamped lock. I can read it, I won't modify it. And once I'm done with reading this variable and processing its value, I can try to validate if someone tried to modify this variable while I was doing that. And if it's the case, then the validate method will return true. So, okay, the variable you've been using has not been modified. Your result is correct. If it's not the case, then this validate method will return me false. So this is a new pattern of code to program optimistic reads in Java with Java Util Concurrent. Great. I've got a new concurrent HashMap. And I'm sorry to say this is some kind of scary piece of code. I'm sorry to impose that early in the morning. The old concurrent HashMap we've been using for 10 years now has completely been removed. So the concurrent HashMap version 7 is not here anymore. It's completely replaced by the new class with the same name, Concurrent HashMap, which is compatible because the concurrent HashMap was is serializable, so it's compatible. Of course, it is still thread safe. It does not rely on locking, which was not the case with the previous version of the concurrent HashMap. And there is a bunch of new methods in it. Let us see that. This new concurrent HashMap is 6,000 lines of code. Who said that a good class was only, how many? 100 lines of code? Okay, 6,000. There are 54 member classes in it, in a single class. Just as a comparison, in the full Java Util Concurrent API, there are 58 classes. So in this single class, there is nearly as many classes as in the whole package. It's crazy. And new patterns of code, which are really amazing. Amazing. So you should not call size on concurrent hashmap. Never do that. Never. Neither in Java 7 and nor in Java 8. Never do that. Instead of that, you need to call mapping count. And what's really crazy with mapping count is that it returns a long. So if you have really lots of key value pairs, you can use the concurrent hashmap. It's a long record. I've got a search method on it. I can search for key value pairs with a predicate. So the predicate is the key value, for instance, value.length lesser than key. Okay, not sure it makes a lot of sense to do that. I've got also search key that takes only the key, search value and search entry. It returns me the first element that matches the predicate, which is really nice. Think of a cache, for instance. And I've got this first argument here, 10. What is this argument? It's a long, in fact. It is called the parallel threshold. It means that if I have more than 10 entries in my hash map, the search will be conducted in parallel automatically. Isn't it that great? I love that one, really. So if you don't want to conduct your computation in parallel, you can pass long.max value. And if you want to conduct that search in parallel systematically, you can pass 0, of course. I also have a for each method that also can run in parallel with the same parallelism threshold. I've got other versions for each key and for each entries. And I also have a reduction directly implemented in that hash map. It's a bit tricky to understand how it works. Okay, I've got this parallelism threshold because, of course, the reduction can work in parallel. I first take a first lambda expression with it, which is the transformation. So I will take each key value pair and transform them one by one in some of the stuff. And this is this stuff that I'm going to reduce. I'm not reducing directly the key value pair. I've got some intermediary computation between them. So this intermediary and computation can be some kind of identity, but it won't be because it takes a key value pair and returns just a single value. But anyway, and then the reduction is the second lambda expression. And I can also reduce key and reduce entries. And it's extremely efficient to do that. It's much more efficient to do that than to do stream.collect.entrySet.stream and reduce that entry set. It's extremely efficient. I don't have any concurrent hash set in Java 7 or in Java 5, in Java Untitled Concurrent, and I don't have concurrent hash sets neither in Java 8 in this API. But I have this new key set method that returns a set, and what is the implementation of this set? It's in fact a concurrent hash map in which the values are Boolean true. So it acts as a concurrent hash set. And I have all the methods of the concurrent hashmap available on this hash set. So in fact, this implementation of hashmap can be used both as a regular map and as a set also, which is great. Well, this was the 50 new things you can do in Java 8. I hope you appreciated all the little diamonds I tried to uncover from you here and then. And I hope you'll remember, of course, that diamonds are developer best friends. Thank you for your attention. And we indeed have some time for questions, so if you have questions, please. Yes? Sorry? Yeah? Sorry, I didn't hear you.
Can you set the now in the date object?
In the date object, can I share?
Can I set the now?
Is it mutable or not?
Oh, no, it's not mutable, sorry.
No, I mean, it's useful for unit tests.
You can provide a time source that you can say this is the time source to get now.
I didn't get the question, I'm sorry.
He was asking if there's a way of when you say in the date time that they try to get now,
Yeah.
specify what now is.
Ah, yeah, what's the now is in get now. Yeah, what is now is now.
No, I mean, in unit tests, it's quite useful because when you are creating an object that eternally
Okay.
gets the now,
Ah, okay.
the unit test,
Yes, true. True. Okay, so you had the answer. Thank you. Other questions?
Your by map example,
Yeah.
isn't it just nested map? I thought by map is when you can map from key to value and back from value to key.
Yes, well, okay, so it's, how do you call that? Well, I'll call that bmap. But okay. Yeah, you mean, yes, I see what you mean. No, this is not a reversing map. Yeah. Bmap is the map of map. Okay, call that a map of map if you wish. No problem. Any other questions? Well, thank you for your attention.